So the Newton's third law is quite simple. So it basically says that if two objects interact with each other, then the forces on them will have the same magnitude but different direction. So if I have an object A interact with an object B and act a force of F80, then the object A is also there's also another force which is FBA acted on the object A, and we have FAB equals negative FBA. And so from that we can have a special force called the normal force. So the normal force, as it says, is normal, so it will be perpendicular to the surface of an object. And this force appears when an object stays on some kind of surface. So maybe if I put a box on a table, right? So the box is pulled out by gravity, right? P, right? Then the box will also like press the surface of the table, and so from Newton's third law, the tables also create another force back onto the box, and we call that the normal force. And the normal force is perpendicular to the surface, and it often also equals mg, which is the gravitational pull. And the surface can sometimes be inclined like this. Then the normal force is still perpendicular to the surface, but the value might not be this. But so you rather write this as like other forces that perpendicular to the surface. So here is the component of the gravitational pull. So yeah, another force is the tension force. You often will see this in maybe ropes or cord. So normally a rope, you put it on the table or something, it would be like this, right? But if you pull the two ends of it, maybe attach it to some object like this, attach these two endpoints, then you can call it that it's under tension. And when it's under tension, every point on the string except for these two endpoints, except for these two, then every point on the string would have two force having the same magnitude but different direction, and they often put it as T like this. Another notice is that the tension force T can be different with different points on the string. So maybe this is T1. In this point, there are T2, But normally um, uh, in our physics problems, we would see these strings as having no mass. And if they have no mass, then T is the same for all points on the um, on the rope. Um, it's like because if T is different, you can have like F of any point on the string different from 0. And if we're talking as having no mass here, it means that M equals 0, right? So this equal MA. So if this is 0, then this must be like infinitely big so that it can be different from 0. So yeah, that isn't just that's not just possible. Another force that I want to talk about is the friction force. So if you're if an object is on an inclined plane like this, then it's pulled out, right? Then if so, then they will have the friction force F like this to keep it from being pulled down. And there are two types. One is static and one is kinetic. So for static, then the friction force is always smaller than the static coefficient times the normal force. So here's the normal force, S here, and to find in these problems, to find F, you gotta find all the forces that is directed the opposite to the F. So it's like and again you just use Newton's first law to do that. It's quite easy. But for kinetic, it's when your friction force exceed this value, and in that situation, it becomes now is the kinetic coefficient and times n again. So yeah, that's about friction force.